So this video is going to be a quick review of trigonometry and some geometry. So to start out with, we're going to talk about the Pythagorean theorem. Then we're going to talk about trigonometric ratios. Finally, we'll talk about parallel and perpendicular lines and finish by showing how we can use those in a physics context. So to start out with, we're going to talk about the Pythagorean theorem. This is something that we use when we're talking about right triangles. So we have a right triangle here with sides A, B, and a hypotenuse of C. The Pythagorean theorem says that a squared plus b squared is going to be equal to c squared. Now, in addition to the Pythagorean theorem, many times we're interested in talking about trigonometric ratios. In order to do that, we need to define some angles. So I'm going to start by defining this angle of theta between A and C. And we'll start by looking at ratios that are related to A and C. So first, we know that by definition, the cosine of theta is going to be equal to the adjacent side to the angle theta divided by the hypotenuse. Now we could look at another angle we'll call phi, and in this case we can say that the sine of phi is going to be the same as the cosine of theta because the sine of phi is going to be the opposite divided by the hypotenuse. Now let's look at some ratios we can build out of B and C. And so going back to defining our angle theta here, we can say that the sine of theta is going to be equal to b divided by c. Again, because sine of theta by definition is the opposite side of the triangle to the angle divided by the hypotenuse. And going back to our angle of phi, we can see that this is also the same thing as cosine of phi. Again, because cosine of phi by definition is going to be the adjacent divided by the hypotenuse. The next thing that we can do is we can talk about ratios that we can form with the sides A and B. And so looking at the angle theta, once again, we see that tangent of theta by definition is going to be B divided by A because tangent of theta is going to be the opposite side, which in this case is going to be B, divided by the adjacent, which is A. Then we can go back to our angle of phi, and we see that the tangent of phi is going to be equal to A divided by B for the same reason. Now, let's look at some principles of parallel and perpendicular lines. So to start out with, let's define two parallel lines here, indicated by the arrows that are in the middle. These are parallel, and we're going to have some line that goes through both of them. Now, defining these angles alpha, beta, gamma, and delta, we can see that alpha is equal to beta, which is equal to gamma, which is equal to delta. And so we can replace all of these with some angle of theta. So that's an important principle of parallel lines. Now we can also look at some principles of perpendicular lines. So imagine some coordinate axis that we have here, some line that goes through it, and some angle of theta that is respect to the horizontal line. Now looking at this, we can see that because those two lines were perpendicular, that if that angle is theta between the horizontal and the line that we drew, then the angle between the vertical and the line that we drew is 90 degrees. Minus theta. Now, the final thing that we want to do is to see, well, what is this good for? Let's look at it in a physics context. And so a common place that we might see some of this is actually just by looking at a block on an inclined plane. So we have a block on this inclined plane. The inclined plane makes an angle of theta with respect to the horizontal. And the first thing that we do when we deal with blocks on inclined planes is to isolate the body, draw a free body diagram. And something of interest here is going to be the force of gravity. F sub g is equal to mg. And you might even remember that we would have this angle of theta with respect to that line that is going to be normal to the surface. But then why is this angle of theta? Well, to see that, what we can do is we can put in another triangle here and then get rid of our large triangle. We can see very intuitively here that this is going to be 90 minus theta, and so by association, the original angle that we were interested in for the force of gravity is going to be theta. So that's it.